Okay. Hello. Thank you for having me. Thank you for being here. And I know I'm probably one of the last things standing between you and your weekend, so I'll try to be brief. My name is Dan Rosanova. I'm a program manager at Microsoft on the Azure team, and I'm responsible for a lot of the messaging services with my team that I've actually heard quite a few people talk about this week, so I'm pretty happy about that. And today I want to talk about what these services are, what messaging services we have in Azure, just as an overview, and when to use them for what. So really quick to start off, who is using any of the Azure messaging stuff right now? Cool. A few people. No offense to all of you. I'm actually more glad to talk to the rest of you because I want you to know what fun toys we have in this box. And I'll start off that I'm really into messaging. I'm actually wearing messaging cufflinks that you probably can't see. And in honor of being in Finland, I decided to wear an appropriate tie, which looks like flowers from far away, but it's not. So thought you might like that. So what is messaging? I want this to be a little interactive. If there's any questions you have, feel free to interrupt me, or ideally not throw things, but throw out questions. So if you're thinking this is what messaging is, I'm sorry to disappoint you. I'm not going to talk about Skype. I won't mind if you get up and leave at this point, if you were expecting that. But I am going to bribe you. So I want to ask questions and be interactive, so I've brought things to give away, including this really cool pen, which is a stylus for touchscreens, a pen, and a flashlight. So I'll probably try and ask some questions and get some interactive response from you. I want to liven things up a little bit. So messaging's not that. It's not this whole sort of chat thing, but it's really not all that different. It's just computer focused rather than people focused. So what are the services we have in Azure to help you do this? We have 3 now. We're really starting to talk about them independently because they all do different things. The first is Service Bus, which is the name that has been around the longest. And when we say this now, we really mean reliable asynchronous messaging. We mean queues and topics. So that's kind of where we'll start off today. The next is Event Hubs, which has had some pretty good mentions already, so I'm pretty happy about that. Event Hubs is a distributed data streaming service. And the last one is Relay. And Relay, or hybrid connections, is very interesting because there's really nothing quite like it in the world right now, and it's about secure two-way communication through firewalls and VPNs, or through firewalls and NATs without VPN. So that's pretty powerful. It's actually our oldest service of the 3, and we're just really starting to innovate on it a lot now. And it's pretty cool when you see what it can do, although it tends to scare people at first. Security people. So where do you use messaging? These are 6 industries that are commonly using messaging. Does anyone work in any of these? Financial services, utilities, insurance, healthcare, government, logistics. Anyone? No one? Really? Okay. Well, okay. So in the financial services industry, what you would see is things like interbank transfers being done, order fulfillment and trading, settlement type stuff, reconciliation, and price updates and quotes. These are just sort of things people do with messaging. In financial services, you'll see a lot of TIBCO in particular, and some MQ, other stuff. When you get into something like utilities, this is usually like, I don't know, phone companies, electric companies, things like that. You'll see they have customer information systems, sort of monolithic applications that they need to get information out of. They're using messaging there. They're doing billing integration with it. They're doing smart meter and smart grid. This is an area I worked in for a long time, and it's pretty exciting stuff. It's all messaging, a lot of messaging. And they're also doing things like command and control over their actual utility networks. So logistics, you see a lot of stuff here for messaging as well. Order processing, like literally taking orders, e-commerce type stuff, delivery notifications, routing, all these fun things. Insurance, there's no one here from insurance, really? Wow. Insurance really likes messaging, so they use a lot of it. And the insurance companies use some cool stuff in our messaging stuff, so I'm pretty happy about that. They're some of our biggest customers in Azure right now for messaging. And they do things like claims processing or enrollment, risk modeling, and regulatory filing. These are 4 that I've worked on with customers on. Healthcare is big, medical records, things like that. And then government. Government uses messaging a lot. The biggest messaging customer in the world is the U.S. federal government. They buy a lot of stuff from IBM. You don't necessarily want to know what they're doing with it, but but they're doing a lot. And that's how they collect all that data, right? They're using messaging platforms for it. If you've ever come to the US and used one of our kiosks to get in the country, like, it's going through a messaging platform. It's not going through Service Bus, but it's going through a messaging platform. So these are kind of very common places that people use messaging. And what do they do with it? We'll get to in a second. This is the full list of, it's not totally full, but pretty full list of areas I have customers in right now. So does anyone work in any of these industries?
I mean, there are a lot of consultants here in the house, so...
So do your customers work in these? Yeah, okay, there. That's more like it. Although I'm still not sure. There's like fish and wildlife or something on here I saw. I was like, what are you doing with messaging? Yeah, forestry and fishing. It's like, okay, cool. So let's start off talking about queues and topics. Quick overview. Who's used any queuing system in the past? Yeah, okay, you're the first one to answer. You get a pen. Yeah, there you go.
Oh, cool.
I'm from Chicago originally, so there I learned to bribe people. That's yeah. I'll get some interaction now, right? Yeah. So queues and topics. What is this? It's reliable asynchronous communication. Kind of a big mouthful to say there. It's about having rich features in your messaging platform for things like temporal control, so controlling the time aspects of your messaging, and being able to do routing and filtering and have a lot of messages related together in like a convoy, something like that. When we look at where does Service Bus fit into your type of architecture, you might see something like this, where you've got a front end, UX, you've got some back end services where you're doing processing, you're probably storing data someplace. So when you're doing these things, this is where messaging fits in. It's putting a queue or a topic in between these components to really give you both decoupling, which is important for a lot of reasons, and also things like durability. So when things restart or crash or whatever, you get some sort of backup from that. So what are common patterns that people do? People do a lot of stuff with messaging. It's a really deep topic. I won't get too far into it, but the first and most common one would be something like load leveling. Maybe you have an ERP system that can't take a lot of load, so you want to kind of protect it so it doesn't get taken down if there's a burst of traffic. That's a common pattern to use a queue for. Load balancing is a slight variation of that. Things like scheduled delivery. Maybe you want to send a message, but you don't want someone to read it for another hour. So that's a big feature, workflow type stuff, when you're building sort of e-commerce things. These are all things people do with messaging. And we give you a lot of features in the platform to do that for you. So features like scheduled delivery, like TTL on a message, meaning if I send this message and no one processes it in some amount of time, throw it away or dead letter it. Poison message handling, which is a fun one. I've worked in messaging, I think 17 years now. 16 years, and that's always something you have to figure out how to do. Is like if there's a message that is stuck in the queue and they start to pile up, you'll poison your system. So we give you tools out of the box to do all that stuff. So we got some fun stuff, and interestingly, having spent a lot of time in the messaging space, I can say that Service Bus is actually the most sophisticated messaging platform in the world. There are others that brag about some features about how fast they can go and things like that. And Service Bus is pretty fast, but it's not like millions of messages a second fast. But all those other platforms just don't have this set of features, this depth of features. And if you're new to messaging, I would check some of them out. They make a lot of your work very easy. One of my favorites is Sessions. I won't talk about it today, but if you're interested in messaging and you haven't used Sessions, you should look into it. That alone is something that makes Service Bus worth having. So basics of a queue, if you've not used it, who's not used a queue before? All right. There you go. Someone's paying attention. So when you have a queue, the queue is sitting here, and the idea is you got a sender who wants to send a message, you have a receiver who you can hardly see on that screen, I think. And the idea here is to decouple these. So the sender sends a message to the queue sends back an acknowledgement that it's received it. In Service Bus, that means that we've triple replicated it, so even if there's a failure in the region, it's okay. Then a receiver comes, receives the message from the queue, takes a lease on it, and when they're done, sends back an acknowledgement to say delete it. I'm done with this. They could do something else like defer or abandon it. But the idea here is that this looks really simple, but it allows you to do really, really powerful things. Like that whole TTL and temporal control aspect. You can keep things in that queue that are safe, they're in the cloud, Your readers don't have to read them yet. They can't see them yet, and then they show up at some point in the future. If you've ever had to do things like stuff that happens at 5 o'clock, like close of business type stuff, well, you could just batch stuff up yourself and wait, or you could just schedule it to all happen at that time. So these are cool features. This is just super basic queue stuff. A little more interesting, we also have topics. Topics and subscriptions are another feature that give us some pretty cool things where you're building even more capability on top of your messaging now. In particular, a topic looks like a queue to the sender. So it looks no different. You just send it to a queue. Receivers actually see subscriptions instead of a queue, so each, you can kind of fan out here. And the important thing is that there are filters on those subscriptions. So they can be SQL 92 type filters. Yes, question?
Can we define the quota for queue? Like when we are creating the queue, so how many messages it can store, like high traffic, so.
Yeah, the question's about defining quotas on queue. So right now, the only real quotas we give you are size quotas. And then in our premium tier, we give you sort of resource quotas, like how fast can you really go. We do not give you a capability to say this queue can only hold 500 things. So which sort of feature you're looking for, I'd like to know afterwards, because we can't help but add features to this thing all the time. So I am interested to know what you want to do, though.
Just a question.
It's a good question. I've never been asked that, actually.
Like in some scenario, if we have too many users and they are requesting and sending messages to the queue, so what will happen if it has some quota? So what will happen with the rest of messages? So
Yeah. So in our system, our queues are quite large. So we don't put quotas necessarily on individual queues. They're there. The big one is a size quota, and it can be 5 or I think up to 80 gigabytes in Service Bus. So you have to fill a lot of, they're small messages, so it takes a long time to fill 80 gigs. But it's a good question. So what's really interesting with filters and actions on subscriptions is that you can do routing. So now instead of having one queue that has a lot of things in it, I think this actually came up yesterday in a conversation I was having about the concept of a universal dispatcher. Like you're reading from a queue and you have 3 messages that could be of different types in there, and the reader needs to be able to take decisions to say, okay, this is an order, I need to do this. This is a quote, I need to do that. This type of architecture helps you avoid that. And an even more substantial thing about this, and this is subtle, because you might think, well, I don't really need messaging, right? What am I really going to get from this? Think about versioning. So you've built something in the cloud, you've got all these pieces, now you're rolling out updates to it. Well, how can this help you do versioning? Well, instead of being a filter on type, it could be a filter on schema, on version. So this is order version 1. All the stuff for order version 1 goes this way. All the stuff for order version 2, when you roll it, goes some other way. And that way you can roll updates without taking your systems offline. So when you get into really big, complicated stuff or long-running stuff, messaging is very critical in helping you out. So it's a pretty mature space. There are a lot of players in it. You'll see things like this in the on-prem market. Messaging's pretty much still driven as an on-prem sort of industry. But that's changing. Enterprises are moving their messaging to the cloud. We'll kind of end there later today. And Service Bus is really driving this move because there's not a lot of glory in running your own messaging stuff. So to make this easier, what we're doing is giving customers sort of tiers that they can choose from depending on what their requirements are. So starting from a very basic, very cheap messaging platform, going all the way up to something that's really a replacement for running like Tibco or MQ in premium messaging. So you get more features as you go along. And the thing about premium is that it's really about predictability. That's kind of where we've gone. Microsoft started our cloud journey really on sort of shared tenant, multi-tenant platforms. What we've learned as we've progressed more into the enterprise space in the cloud, where we're doing pretty well actually, is that enterprise customers don't necessarily want multi-tenant stuff. A lot of enterprise customers are really concerned about availability and predictability, so they want things that they can rely on. And so we are doing as much as we can to support that with things like predictable performance, so resource isolation, predictable price, daily fixed pricing instead of variable pricing. So we know that predictability in price is also important to enterprise customers. They want to know what something's going to cost 2 years from now. Larger messages and, of course, higher scale, because, yeah, premium can also do that. And then, importantly, we're going to be innovating more on premium because since it's resource isolation, like those features that I mentioned, things like transactions, they cost CPU, so they cost resource. So there are some features that we can't add to a multi-tenant platform for financial reasons. But if it's resources you've purchased, we can put all sorts of things in there because they're your resources. So we'll continue adding stuff there. Premium is, to some extent, though, about performance. And these charts are good because you can see that we've built a platform that scales very linearly. The smallest thing we sell for Premium will do about 4,000 messages a second through a queue. And then we sell it in 3 sizes that are doubling every time. So you can see it scales pretty evenly. I think the top number is 16,700 something. So they're different colors because they're different use cases. So depending what you're doing, you'll get different speeds. Yes? So I have a graph for standard. That's a good one. Standard is a multi-tenant platform. So the issue with that is it's like back testing a stock model. Like just because my trading model did well yesterday in the market doesn't mean it's going to do well today. So how fast you go on our standard platform depends on how busy we are. So there's times when you could go faster than this potentially on standard, but there are also times when you go a lot slower or will you get latency because sometimes you'll get 20 milliseconds. Sometimes you'll get 2 seconds. Premium takes all that away. Great question, though. Yes?
Does the graph have opening the connection, basically making the subscription, or is it just, the subscription is open already, and this is about sending messages?
This is pure message throughput, yeah. So it's not about creating stuff.
It's actually, the subscription creation is the time-taking part there. Those at a rapid pace, that's going to be the one that causes latency in the application instead, and not the message sending.
That's true, and that's if you're from a messaging background, there are different styles of messaging, and some are more dynamic messaging sort of uses. That's kind of big in the JMS world, where you'll have topics that only exist for a minute or something like that, and we're not really kind of built for that. We're built for more durable stuff. But yeah, you could still do a lot of CRUD operations in it. The important thing here is they're your resources. So if it takes you a second to create a topic, it'll always take a second to create a topic. Whereas in standard, it depends how busy we are. Yeah. So yeah, good question though. So now on to Event Hubs. Let's see, how am I doing on time? Pretty good. So Event Hubs is a pretty exciting service. It's been out for 2.5 years, GA'd for just over 2 years, and it is a distributed data streaming platform. So does anyone know what Kafka is? Anyone heard of Kafka before? It's an open source platform. So it's like that as a service. It's really about streaming telemetry, streaming data at low latency, high throughput. That's really what it does. It's different than a queue, which we'll talk about in more detail in a second. But if you think about a queue as like a table in a database, you have locks on the rows, people are putting things in, taking things out, and that's called a competing consumer model. So like a queue and a database are very similar that way. This is not. It's a partition consumer model. So that's kind of how, like sharding and yes?
How much do you got with HD Insight team? Because Kafka's coming there.
Yeah, the HD Insight team. They do have a preview for Kafka on HD Insight. Yeah, and for people who love Kafka, which, yeah, there are some out there, that they can have that as an option.
Thanks for the answer.
Yeah, well, a lot of companies want to use open source, and so we're doing as much as we can to make that easy.
And they have the knowledge already. So.
Yes. So this is a different thing. It's more similar to Kafka than it is to queues, and it's a time retention buffer. So the concept works differently. I think Saravana said that earlier today. Is about how the data doesn't go away in Event Hub. Like in a queue, you read the message from the queue, it's gone. In Event Hub, it works differently, it stays there. But it's an elastic component that can really help you build more durable chains or pipelines. So when you look at where does this fit in for things you're building, this is the architecture we commonly see for telemetry in Azure. If you change the boxes, it could be some other cloud platform or somewhere else, is that we see this is a one-way flow from, which side is that for you, from the left to the right, of data coming out of devices, coming out of servers, coming out of stuff, moving into the cloud, and then moving further down. And what we typically see all the way to like presentation and action, so where people interact with this stuff. What we typically see, though, is that customers want to do 2 different scales or speeds of things with data. You want to do very fast stuff like anomaly detection and alerting, and then you want to do slower stuff like big data processing. And so our goal is to allow you to do both very easily. So we focus pretty hard on this. Common patterns, what do people really do? Device telemetry is a really big one. We get a lot of that. Application logging is probably our largest. People want to log stuff in their applications. Application telemetry, which is different. So application logging might be, okay, these methods are being fired. This stuff is happening. Telemetry would be more for like performance. Like typical request response time is taking X. Now it's taking Y. So you can actually watch two different types of telemetry coming off your same system. Things like user telemetry, so clickstream analytics, that's actually getting pretty hot. People wanting to do live clickstream analytics very quickly so they can change what people are doing on their websites and in their applications. So these are kind of the things people do with Event Hub. And we give you a lot of features to make that easy. We have Archive, which is new. It's an archive feature, which is kind of funny because we worked very hard to make Event Hubs very fast and then realized that a lot of people don't want to go fast. We still live in a batch world, so that's kind of, we have to face reality and help people where they are. Got to go to the customer. Proximity, so you can have your data together. I mentioned that this is a partition consumer model, but sometimes you want your data together. We give strict ordering if you're using that feature. So the data is in the order in which you sent it, and it will be consistently in that order no matter how many times you read it. And it's something that can do tremendous scale. We do have customers like the Halo team, Halo 5, using Event Hubs where they're doing over 1 million messages a second regularly. And they're doing it very quickly, too. So all of the Halo 5 telemetry goes through Event Hubs. It's cool stuff. So you're the first audience to see what I'm going to try and explain how Event Hubs really works with this analogy. So first I want to ask, who knows what this is? Is any of us old enough to remember these? Okay, cool, good. First I was worried when someone was like, hey, are you sure? Do people know what that is? I was like, uh-oh, maybe not. So I'm thinking of how is Event Hubs different from a queue? Event Hubs is more like this. It's more like a tape. So it's recording a stream. That recording is just moving forward. So it's not like a queue, which is random. It's really just moving forward. And you can play the tape over and over again. So in my mind, this is working pretty well. Hopefully it helps you understand what this is. And in reality, Event Hubs is like, anyone remember what these are? Anyone who had one of these? You know what? You get a pen too. There you go. So it's kind of like this, right? You're having something that you can play this tape from. You can play from anywhere on the tape. You just fast forward and rewind to get to that point in the tape. One slight difference on this, and some of these things did this, was that the tape will loop when it's done. So it'll go back or flip sides or whatever. So basically it's a loop of stuff. Eventually the data ages out and it'll be re-recorded over. Event Hubs has a concept that's critical to it, to this partition consumer model of partitions. So instead of everyone fighting for a resource, which is a competing consumer model, partition consumer model means that you have many resources and people just use one resource for them. So a way to think about this, trying to keep this theme going for cassettes, is that a cassette actually has, or CD, whatever, audio we listen to, has two channels, a left and a right channel. They can actually have totally different stuff on them, which can be really weird if you're listening. Actually, really, like kind of old records will have different audio on the left and right. Like people used to put like drums on one side and guitar on another side. So when you press record on one of these things, you're recording both channels, but they're actually two different channels with different data on them. So that's exactly how partitions work in an Event Hub. And if you look at one of these sorts of things, the left and right speakers on a boombox are there because they're playing two different channels of data. We call these partitions. So if you just think about what are channels on audio, it's the same thing as partitions in Event Hub. And you could think about it that being a speaker is like a reader, right? So to play back, you need a speaker. So you typically see this thing on the right. We can give you more partitions. You can have lots of partitions in Event Hubs, and you get more and more speakers. Now, at some point, I'm not sure how useful they are. I've never seen one of those. That would be kind of funny to carry around. Have like 2 or 3 people carrying it. So you can use partitions in this way. I don't know. Simple is good in my mind. Here's the way I used to describe Event Hubs. So hopefully you can tell me in a second if you think this way is better or that way. Is that an Event Hub looks kind of like this. There's partitions inside of it. All the partitions have data inside of them, and they're all separate from each other. So you're sending your data in. Your producers just send data into the Event Hub. When you go to read the data out of the Event Hub, you have a receiver for each of the partitions. They connect through a consumer group, and now they're reading the whole stream of data. And you can have more readers through different consumer groups. So you can have a lot of readers at the same time. The big concept here is that this is a client-side cursor. So like the client says, hey, I want to connect at position 26, and then read, and then play the tape, read forward, which is different than a queue, which is a server-side cursor. So you just say, give me the next message on the queue. So I know some of these things sound kind of subtle, but they're actually pretty big differences when you get into using these things in the real world. So which of these two ways is better to explain this, do you think?
I like the latest one. I think it's about audience. If you have developers, this one had more information, I think.
Okay, fair enough.
You didn't notice the consumer groups in the previous one.
Yeah, I couldn't think of a good way to describe that. I thought I was pushing the analogy too far.
Maybe there's some snot or something on the boombox.
Yeah. Good feedback. So the other aspect to event hubs is throughput units. So now you know the mechanics of the event hub. There's partitions, there's data in the partitions. Throughput units are the thing you're buying to let you go fast on event hubs. It's how you change your speed. So whereas some systems you might have to reshard if you want more speed, we don't make you do that. We just sell you throughput units. They're reserved capacity. It's entitling you to 1 megabyte per second or 1,000 events per second of ingress and twice that amount of egress. So I was going to try and push the boombox analogy here too, and I decided against it. When you hit these limits, so these limits are namespace wide. That's namespace for us. It's a fully qualified domain name. It's like a storage account in Azure. When you hit the limits of what you've purchased, you get throttled. So we'll tell you, hey, you're at the edge. You can't go any faster. You can always buy more, but this is a way to help you control like how much data do you really want coming in. Like, the scary thing about the cloud is if you have unlimited scale, someone could really hit you with unlimited scale. And do you want that? If you're making money off of it, probably, but if you're not, maybe not. So pricing an event hub, this is good stuff too. Don't want to talk too deep about this. We have 2 tiers. We're trying to do the tier thing to better fit what people need. Event hub's pretty cheap. We charge for ingress events. It's 2.8 cents per million. It's a tough way to make money. And then we charge hourly for throughput units, which is 3 cents an hour. So we do have more features as you go up. We actually have another tier we don't really talk about. It's dedicated capacity. If you need really, really big clusters, if you need to do 1 million things a second, that's what you would use. Do you have a question, Alan?
Did it used to be 7 days message retention?
Sorry?
Did it used to be 7 days message?
Did it used to be 7 days messages for retention? No, the question is, did it used to be 7 days messages? 7 days for what?
Message retention.
Message retention, yes. So we give you, so you can choose the message retention time in event hubs. Like that's one of the aspects that you get to control. In basic, you don't get to control it. In standard, we give you a day for free, and then if you want more, you can pay for more. And it's all we charge you is the raw storage cost, which is quite little. So yeah, but you can go up to 7 days in standard. But we don't want it to be looked at as a long-term storage thing. So we don't really know if there's use for that beyond 7 days. Here's a good pricing example. A throughput unit at 3 cents an hour is going to cost you 72 cents a day. You could send at 1,000 messages a second, 86 million messages through that. And that would cost you $2.42 a day. So your total for the whole day and 84 gigabytes of data is $3.14. You can't even buy a coffee for that. I usually drink fairly cheap coffee at the office, so I guess I could. Plus someone else is buying it. But yeah, I mean, it's a very, very affordable service. And it scales. It scales really well. So people kind of think, oh, I have big data, I have big business, I need all this stuff. Maybe I need to do 1 billion things a day. Right? I need 1 billion events a day. What's that going to cost me? So you would need about 12 throughput units to do that. You can get this on the portal right now. Setting up an event hub literally takes 30 seconds or less, and it's fully provisioned in there and ready to use. So you'll need 12 throughput units. That's going to cost you 3 cents per hour per throughput unit, $8.64. And then to send that 1 billion messages at 2.8 cents per million, it's awesome, is $29. So at the end of the day, you're looking at just under $38 to stream 1 terabyte of data with sub-second latency into Azure. So, I mean, if you can find a cheaper messaging service anywhere, by all means use it. I will not be offended. But, like, this is a good... it's a compelling service, I can say that. The funny thing, though, is I mentioned how we strive to be very, very fast, but the majority of customers actually want to go a little slower. Everyone wants to write to a persistent store, which introduces its own set of problems, because if you have this thing that can do tens of thousands of messages a second without even calling us, millions if you do, and then you want to point it at like a relational database, you're going to have a problem. Like the relational database is a competing consumer. There's a limit to how fast it's going to go. So we're trying to help people do that. We introduced this archive feature. Archive is a way to take your data that's coming in as individual events, kind of batch them together into larger files, and then put them in a storage account that you provide to us. So we're really trying to reduce your overhead, like how much you have to do. This has come up a few times actually during this conference, and it's somewhere I think Microsoft is very strong, is in the PaaS space. What we're very good at is finding where you have to do stuff in code and then run that code and help you make that go away. Like, because we're trying to eliminate the unnecessary work you have to do. Code is cost. So how does archive work? Here's our friend, the Event Hub. You might remember this from 5 minutes ago. You give us a storage account. You give us a window of time and size. And then what we will do is when that window gets filled, we'll create files for each of the partitions in the Event Hub. So as that window fills up, we give you more and more files. The files right now have a fixed naming convention. We are changing this so that you can change the order of the naming convention and put some prefix and suffix type stuff in it. So that was feedback we got. We're doing this. Archive is in preview right now globally, every region in Azure. Event Hubs, all of the messaging services are in every region in Azure. So this is really designed to automatically send your events to storage. There's no code for you to have to run. It's really meant to enable you to do batch and real-time on the same pipeline, so that you don't have to send data twice. You don't need two pipelines. And it's really also designed to let you use your existing tools and processes. I said half-jokingly that the world is still batch. It really is. Like, a lot of code out there is still batch. A lot of systems are still batch. And what we want to do is let you use your batch processing that you have, but through a pipeline that will let you do real-time analytics in the future. So even if you're still doing batch today, this is an easy thing to use, and it will help you grow into a place in the future where you can do fast and slow together. So no code, easy. Try it today. It's out there. It's fun. It is the easiest way to stream data into Azure. Like, Event Hubs lets you do HTTP post. Like, post your data and it shows up in a storage account. It does not get much easier than that. Pause for a daily moment of Zen. Take a deep breath. Okay. All right. So, last one, relay and hybrid connections. This is a fun one too. This is the one where we usually scare the security people. It allows you to securely connect to on-premise data from anywhere in the world. So this is why security people kind of get nervous from this. It allows you to load balance connections to that on-premise data. So if you have maybe 2 different data centers in different places, you can load balance traffic between them. It lets you project an internal service to a public endpoint and protect it with Azure being in front of it. So rather than your service callers knowing where your service is in your data center or using a VPN or something, they're actually talking to Azure first. So all of our sort of network protection stuff that's built into Azure is in front of your service then. And it doesn't require any network changes to do this. So this is the magic of this, and we'll talk through what this really is in a second so you can see it. So this is very good. Like, where does this fit? This is very good for when you have solutions that'll look more like this. Like, you have data, you have people wanting to get that data, but you have people all over the place wanting to get it. So if you have too many of these connections like this, something like a VPN is not really going to be a cost-effective solution. Maybe think about like salespeople in the field. If you have 5 salespeople, sure, give them all a VPN. If you have 5,000 salespeople, that VPN is going to be pretty expensive to run over time. You're going to need some pretty specialized equipment to do it. So it's very good for some scenarios like that. It's also really good for when you have to keep data in a certain place. So maybe you have some data in Europe and personal data, and you can't, let it go to the United States. Like, this is common. This actually, people think that's the big thing. It's really not. We have these laws in the U.S. too, like medical data, legal data. There's requirements about where that data can live. So most countries have these types of laws about data sovereignty, where data can actually be. Some of these laws make sense, some don't. that doesn't matter. They're laws. We got to follow them. So this lets you keep the data where it is, access it from remote without moving the data out. So this is a fundamentally different service than everything we've talked about. What is this? What are the patterns for this? It's really about frictionless connectivity. That's what people are doing. And we give you a lot of features to support that. I jumped through that pretty quick, actually. I think I said all those, though. So it's hybrid is what we're going to talk about. Like, how is this hybrid cloud? We're giving you features to support this, WCF or WebSocket transports. We're letting you choose your communication style, whether that's one-way, request response, or peer-to-peer. We're overlaying an additional security layer on top of this, giving you geo-distribution, endpoint discovery, all these fun things in the box. But what does this look like, right? So how is this working? It's a proxy, really, is what this is. Unlike the other services before, which are brokered messaging, meaning like you're sending a message, it's being stored somewhere, and then someone else is coming and reading it, which is asynchronous. This isn't like that. This is like a live socket. So this is the basis for all of our hybrid stuff that we're building in Azure. And it's really used to decouple location, security, and network configuration. So if you look at a typical client-server scenario, it would look like this. You have a client wanting to talk to a server. Has anyone ever worked on a system like that? I was hoping to see a lot of hands here. Okay, good. You can all have stickers after this. How you go. So today, everyone would have firewalls in front of these things, right? Because that's the sensible thing to do. The problem there is that you're trying to get data from that service. Firewall is going to stop you. And here's where Azure comes to rescue. So let's look at this again a little bit differently. This is what Relay and its new cousin hybrid connections, which is WebSocket based. This is what they bring. We sort of turn it around. So the service connects first to Azure. And it says, okay, here, I'm ready to talk. People now can connect to me. It's an outbound connection. That's why it's going through the firewall. Those are usually not blocked by firewalls. And the clients go talk to Azure instead of talking to the on-prem piece. And we make network magic happen. So at a little deeper level, what's it look like? It's a rendezvous is what's happening. Is service connects first. Here's our cluster. Our cluster is bigger than 4 machines, but for illustration purposes, I thought this would be easier. Server opens a control channel to Azure. Client comes along and says, hey, I want to talk. They send a message in. It lands on some server. We talk to the server that the other service is connected to, and we send that control message that says, hey, go connect to that exact machine where the client is connected in Azure, and now we can bridge your sockets. So it's literally read from one socket right to the other socket. So that's kind of how this works, and it's bi-directional. So like unlike REST type services where you have to do, like HTTP, people love HTTP, but it's a very strict protocol. You must do request, and there will be a response. Like that's the HTTP protocol. This isn't that. It allows you to do things like open a socket, and either party can send data whenever they want. So it's very, very useful. It's very popular with ISVs. And it's a service that if you haven't played with yet, it's pretty compelling because you can do things like forklift applications in the cloud that way. So maybe you want to put your front end in Azure, like your web front end, because it's cheaper to run it in Azure, but you don't want to move your Oracle database to Azure. Well, you can leave that on-prem and access it. Or maybe that data is sensitive so it can't be put into Azure. Or into some cloud provider. So you can leave the data where it is. So Relay's pretty cool. Who's worked on Relay ever before? Yeah, I know you have. You don't count, but I think you already have a pen. So yeah, cool, good. Well, take a look at it, especially with hybrid connections. It's new. It's fun. It's powerful stuff. Messaging. How much messaging do people really do? This is a good question, and I do have to update this a lot because it changes a lot. People do a lot of messaging. In the month of December, we had 17.45 trillion requests to the messaging services in Azure. That's 6.5 million a second. In the hour I've been up here talking, it will be an hour and 10 minutes. That's 23.5 billion messages. Or events. Over that time, in December, I actually ran these last night to make sure they were accurate. We had 99.9984% success rate. So that's pretty reliable, pretty fast, very low latency. So we push for that. So yeah, messaging's big. People do a lot of it. We have a lot of customers about... I shouldn't say that, actually. I won't say the next number. That's okay. When we turn off the camera, I can talk some more. Other cloud messaging, kind of coming full circle here, Exchange. So running a messaging server is kind of a difficult business. Who's ever been responsible for running Exchange? Anyone? Anyone ever use Exchange? Okay, so Exchange Online has been like that was the first killer app in the cloud for Microsoft, really. That was the first thing where people were like, even IT departments, please take this thing away from me. Because there's no glory in running your email server, right? Because does the executive ever come up to you and say, hey, you do a great job with the email. That's awesome. No, but if it's down for 10 minutes, they're all yelling at you. Like there's no benefit to doing this. And so it's interesting that this type of messaging was really the first big shift to the cloud. And now the big shift happening is other types of messaging, other type of utility computing services. And all of the messaging stuff I've talked about today fits into that category. Because the funny thing is there's really no benefit to running your own messaging server. Even when you think it's a good idea, it probably isn't. I'm an American, if you couldn't tell. In a few hours, we will have a new president in the United States. If you had asked her about running her own messaging server, well, you'd probably get some interesting feedback there. Thank you very much. I'll be around for questions, and we can take questions now. And thank you, everyone, for coming here this week. This has been a great conference, and it's been a pleasure to be a part of. And it's great to see such a strong community here for Azure and for Microsoft. And then, since I always put a picture of my dog in my presentations, there he is. Okay, questions? Ideally not about our new president. Okay. All right, then.
Questions about it?
No. Okay. Yeah, thank you. Yes. All right, well, thank you very much.